Welcome, ladies and gentlemen, boys and girls. Today we're going to solve another coolest problem, which is diameter of binary tree. So this question is very good. It's quite simple as well. So what the question is saying, like we are given the root of a binary tree and we have to return the length of the diameter of the tree. Okay. So what is saying like the diameter. So we have to find its diameter from the root to the leaf node. Okay. So that's what they are saying in this complete thing. Okay. And the length of the part between two nodes is represented by the number of edges between them. Okay, so how it will represent? It will represent the number of nodes between them over here. So let's say like this is our root, and then these are three leaf nodes over here. So this one has this one has size of 2, this one has size of 1, 2, 3, and this size of 3. So it will choose any one from of these two threes. Okay, so it will choose any one from of them. So that will be the diameter. Okay, so guys, I hope the question is clear. What the question is saying. Now the things from like how we gonna solve this question. That's the main thing. Okay, so to solve this question, what I'm thinking like, okay, dude, let's say like initially our I will call my sum is 0. The max sum will be our 0. Okay, because we don't know what the diameter is. So to get the diameter, I will make a function call. So that function call will help me to traverse the tree and get this diameter on the left side and the right side as well. Okay, so by creating that function, what I will do, I will traverse on its left and I will traverse on its right as well. Okay guys, and what else I can do, I will just simply use the math.max function and get maximum from the previous max we have. Let's say if we have any previous max value of, let's say this is 2, then it will compare of the new one of left plus right. You know why left plus right? Like let's say it's go over here, so it's the left plus right. Okay, so left plus right. Okay, and finally I will return the maximum of, again, the math.max of what, left and right plus 1, left and right plus 1. So if you don't understand, don't worry, I will code it up and then you will definitely gonna understand. That's my guarantee. So that's how the approach I'm thinking to do. So guys, ladies and gentlemen, without wasting any further time, let's start solving this problem. Okay, so first of all, what I will do, I will globally declare my max sum over here. So this will hold the maximum value. Okay, and let me create a function called max depth. So this will initially has my root and I will return my max sum which we have created over here. Okay guys, now what I will do, I will simply make a function call over here, public int what max depth of tree node root. Okay guys, and I will create one base condition. My base condition will be, let's say if the root is null. Okay, the root is null, then I will simply return 0 over here. Okay, so that's the base condition. What else I have to do? I have to go on this left and go on the right as well. The maximum depth I can go. So I will say int left. So it will tell is the maximum depth on its root of the root left. Similarly, I will go for the right as well. So max depth of root dot right. Okay, so I also this thing is like what I'm doing over here. Okay, so now here's the things come. What I will do, I will say, okay dude, so we have max sum. The maximum will be updated with math.max or the previous maximum value, and the new left plus right which I'm getting. If I'm getting any left plus right, or if I'm getting only the left, or if I'm getting only the right. Okay, so that's what I'm doing over here. And from this one, I will simply return my math.max left comma right. So from any one of the side we get the maximum. I will return it, and I have to add plus 1 as well. Why plus 1? Remember, I have to add the root node value as well, because this root node consists of 1 as well. So 1, 2, 3. So that will be 2 plus 1, 3. Okay, so I have to, that's all the code is, and I have to, it's clear. It's not too hard. Let me just give you again quick overview if you still don't understand, but I hope so you have to understand. This question is very simple. So it's like I declare a global variable over here in the max sum, so it will hold the maximum diameter. Okay, the diameter which is the maximum value, and I will traverse using this max depth function. I will traverse on his left, on his right. I just create I'll make a base call over here. Okay guys, and what else I'm doing over here, I just simply say okay, do one thing, get the maximum from using math.max function. Maximum, if it has any previous maximum, then go for check. If don't have, then go for the left and it's right. If it is left and if it is right, and return the left or right which one has the maximum one with adding the root value plus 1. Okay, so that's all the code is. So I hope so it's clear. And let me just give a quick run here to see are we facing any compilation error over here, and here we go, ladies and gentlemen. So it's accepting very well. So let me just, ladies and gentlemen, submit this code to see any missing task. It's accepting all the tasks. Let me just talk about time complexity and the space complexity, ladies and gentlemen. The time complexity in this one we are dealing with big of n, as like we are we are traversing n number of nodes deeply. And the space complexity in this one is we are dealing with big of n as well. Now you will ask why? Because we are using variable of a constant size. I will say, listen, we are using variable of constant size, but it will still hold an additional memory in a function called stack. So that's the reason. Like we declare it over here globally. That's why. So I hope so, ladies and gentlemen, now everything is clear. If you still have any doubts, just do let me know in the comment section. I will happily to answer your question. And thank you, ladies and gentlemen, for watching this video. I will see you in the next one. Till then, take care, bye bye, and I love you guys. Believe me, I love you. Take care.